Alright, so today we're going to talk about the Pythagorean Theorem. Okay? So, the first thing is we need a couple of definitions. First definition we're going to look at is definition of a leg. Not what you walk on. This has to do with triangles. The two sides of a right triangle that form the right angle are called the legs. So if we look down at this triangle down here, the two legs are going to be the one on the left, which we usually will call A, and the one on the bottom, which we'll usually call B. Those two are the legs. They make the right angle. It really doesn't matter which one you call A and which one you call B. They can be switched around. But the two legs of a right triangle are usually labeled with A and B, and they are the legs. The other side is called the hypotenuse, which you can see it's the side opposite the right angle. So if we're looking at this triangle down here, here's the right angle. That right angle is pointing to this side. That's the one opposite it. And that is usually labeled with a C. So the two legs are A and B, the hypotenuse is C. So the Pythagorean Theorem itself, what it says, you can see right on the screen, it says, in any right triangle, that's important, it does have to be right triangles, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Sounds like a whole lot, it sounds very confusing, but it's actually not too bad if you take it piece by piece and see what everything means. First of all, it says the sum, which we know means we're going to be adding something. The sum of the squares of the lengths of the legs. In other words, however long this side is, whatever A is, and however long the bottom is, B, you just square them. So you have A squared, and you have B squared. And it said that we were going to take the sum of those things. So we have A squared plus B squared. That's what all of this says. The sum of the squares of the lengths of the legs would be whatever A is squared plus whatever B is squared. And that equals the square of the length of the hypotenuse. Well, the hypotenuse is labeled as C, so that's just equal to C squared. That's it, that's all it means. It says if you take this side and square it, and take that side and square it, it should be the same as this side squared. In fact, it doesn't even say it should be, it says in a right triangle it has to be. So, in other words, let's say that A was 3, and B was 4, then that would say that 3 squared plus 4 squared should equal C squared. Well, 3 squared we know is 9, 4 squared we know is 16, and 9 plus 16 is 25. So that means C, if you think about it for a second, you should be able to figure this out, should be 5. Because if I square 5, I get 25. Then I will have the sum of the squares of the legs, A squared plus B squared, coming out 25, and I'll have C squared coming out to 25. So the sum of the squares of the lengths of the legs will be equal to the square of the length of the hypotenuse. So it sounds like a lot, but it's actually very simple. And we can use the Pythagorean Theorem with right triangles. If we have two sides, we can find the third one, which comes in handy. So if you look at this problem, it says the two legs of a right triangle are 5 and 12. Find the length of the hypotenuse. The first thing we're going to do, anytime we have a problem with a formula, we always write down that formula first. So we're going to start by writing down a squared plus b squared equals c squared. And then we just plug in what we know. It says the two legs are 5 and 12, so those go in for a and b. And it doesn't matter which is which, I'll just put 5 for a, 12 for b. But I could easily switch those around, it won't change anything. So now I have 5 squared plus 12 squared is c squared. And now I just square everything. So 5 squared is 25. 12 squared is 144, and these we should know. And 25 plus 144 will give me 169, and that's what c squared is. So, as we were talking about the other day when we did square roots, if I want to know what just c is, this is an equation to solve. I do the opposite. The opposite of squaring is to take the square root. So that'll give me my c, and the square root of 169, one of the ones we should have memorized, is 13. I go back and I look up my units for centimeters. So 13 is going to be centimeters. So that's it. Every one of these problems will actually be the same. You're always going to start by writing on your formula. Then you plug in what you have, square those, add them together, and then you just have to take the square root to get what c is. And that's it. Similarly, this problem, we actually have the hypotenuse, because the hypotenuse is 15, and we have one of the legs, we need to find the other. It's very similar, and almost every step is the same. There's just going to be one step that's different. We will start the exact same way. We'll write down the formula. A squared plus b squared equals c squared. And we'll plug in what we have. Well, this time we have the hypotenuse is 15, so that has to go in for c. We also know one leg is 12. I can put that in for a or b. It doesn't matter. So I put it in for a. I have 12 squared plus b squared equals 15 squared. And now, same as on the last one, I'm going to square everything. I wrote the formula, plugged in, squared everything. I'll do the same over here. Formula, I've already plugged in, now I'll square everything. So 12 squared, we know is 144. Plus b squared equals 15 squared, which we should know is 225. Now, here's where the difference is. On the last problem, these two numbers were on the same side. So I just had to add them up. On this problem, they're on different sides. So really, I'm solving an equation here. And so if I want to get the b squared by itself, I'm going to have to subtract the 144 from both sides. If I subtract 144 from both sides, then I'll just have my b squared left over. And 225 minus 144 will give me 81. Now we're at the same spot we were on the last one. We had c squared equals 169. We had to take the square root. Same here. We have b squared equals 81. So we're going to have to take the square root. And that'll give me my b, and the square root of 81 is 9. And these were in feet, so the 9 is going to be in feet. So that missing leg would be 9 feet. So again, these are always, if I have two sides, I'm always going to follow the exact same steps every time. I'll write down the formula, plug in, square what I have, and then depending if I have the two legs, I will add them together. If I have the hypotenuse in one leg, I will subtract them. And then I will be the same spot in both cases. I'll have something squared equals a number, and I'll just have to take the square root. And that's it. It's the exact same steps every time. And there's one other kind of problem that we can use Pythagorean Theorem for. It's to see if these three are the sides of a right triangle. Which we'll talk about this tomorrow in class. This is actually very useful when it comes to building houses or other buildings. You can use Pythagorean Theorem in this way to check to make sure that you actually have your corners at a right angle like they should be. Alright, so the way I check if this is a right triangle, if it is, it has to fit the Pythagorean Theorem. So in other words, a squared plus b squared has to be c squared. Now, the hypotenuse is always going to be the longest side of the right triangle. So I can just look at the numbers and know which one has to go in for c. In this case, that's 20. The other two can go in for a and b, doesn't matter which is which. And then I just square everything. I get 144 plus 256 equals 400. And when I add 144 and 256, I do get exactly 400, which is what I want it to come out to be. So that tells me that, yes, 12, 16, and 20 could be the sides of a right triangle. If these two do not come out to be exactly the same, then the answer would be no, there's no way there can be a right triangle. And that's it. So that's how you can use Pythagorean Theorem to check those.